So in this video we are going to construct binary search tree if you have given already the pre-order traversal. So let me understand what is the pre-order traversal and what is the binary search tree. The main property of binary search tree, it is different from binary tree actually. So for the BST, we also call the BST in short, binary search tree. The main property is that wrapped child must be smaller than the parent child and the parent must be smaller the right side node. If you see here, take one small here, 8, 5 and 10. If this is the parent, we also call the O, this is the left and this is the right. You can see always left side is smaller than the parent and parent is smaller than the right. And it's applicable to all the subtree also. So forget about the 8. If you take the 5, 1, 5, 6. See, 1 is lesser than 5 and 6 is greater than the parent's 5. See, this 7 is greater than the parent's. This 10 is greater than parent's because this is the right side and this is also the right side, that is the greater than the parent. If anything want to this side here, that must be greater than 8 and the less than 10. So if 9 is here, you can say this is the binary search tree. So binary search tree, always keep in mind that left side is the smaller than parent and the right side is greater than the parent. This is the property for the binary search tree. And you know what is the traversal? Pre-order traversal. In the pre-order traversal, what we will do that? We will take the first parent, then left, then right. So take the first parent, 8, then the left. So the moment you come to the left, again you will encounter this is the another subtree, right? This is the another subtree. So for this subtree, what is the parent? Parent is 5. So put the 5. For this parent, what is the left? 1. Put the 1. So left, parent, right. What is the right? Again you encounter one subtree. So for that, what is the parent? 6. And there is no any left. So you skip the left and the right is the 7. We have done the left side subtree. If you see the right subtree, again this is the one subtree, right? And what is the parent for that? 10. We don't have the left child, right child is 15. So this is the actually your pre-order. So in the program, in the problem, you have been given already the pre-order and from that you have to construct the binary tree either in the pictorial form or the array form. What is the array form for this binary subtree actually? When you denote through the array, so it is like this, right? Wait first search kind of. So 8, 5, 10, go the horizontal, 1, 6. But if you see here, there is no any left child. So put the null, then 15. Here again, there is no any left child, right? So no left, no right. So you have to mention again null, null, and there is no any left here. Means we are missing this left, we are missing this right, we are missing this left, we are missing this left, right? So for that, this null is represent this one. So this is null for this one, this is null for this one, and this is another null, and the same. So this is the array form of this binary search tree. So in the problem, you have been given this the pre-order and you have to construct this tree or this formula, right? So now how it is working actually. So the main important property, two property you have to keep in the mind. First property is this one, that BST left is more than parent, parent is more than the right. And for the pre-order traversal, first node is always the parent or the root. So in this case, you see 8 is the parent, okay? And now we got the parent. Now we have to find out the left subtree. We have to find out this one. So as I know, the left side is must be smaller than the parent. So we have to traversal from here. So suppose if this is your in P start, suppose if this is the array and this array name is the pre-order and this is the P start is equal to 0. So from the P start plus 1 means from here we have to traversal till lesser than the parent, lesser than the root. In this case, we have the 8. So we have to move one by one and check the each element till lesser than the root. The moment, and you can denote this is the position. This is the position. Position means integer variable. So this time I keep it here, next here, next here, next here. The moment your variable position will come here, that means you understand that before position, that we will see in the code, before position that and after start. So P start plus 1, P start plus 1 till position minus 1. It is become your left side subtree. So starting time, I will make this 0. I will keep this P start is equal to 0, and I will mention this P end. P means pre-order end. And what is size of pre-order means? 0, 1, 2, 3, 4, 5, 6. So we start from here. So then this is the left side, and right side is the position from position to P end. Right. So you got the two arrays, right? One is the 5, 1, 6, 7, another is the 10 and 15. And from here we already got my parent is the 8. So whatever you have done here, do the same thing here. So in this case, again this 5 will become your root. This 5 will become your root, and start from here. Means if this is your P start, so start from P start plus 1 and go move till you get the till less than your parent. Parent is 5. I will move from here 6. 6 you call the position. So this time we got only one element 5. This one 1, right? So 1 is the left side and right side is the 6, 7. 6, 7 and 5 is your root. So now this is 8 and 5. In this case, obvious, this is the first element, that is the root. So if you see, this is the root, right? Again, in this case, this is your P start. So of course, this is the P start plus 1, and your position would be also there, and there is only one element, right? So the moment you only one element, this is the right side. So put it here, right? And if you see here, so you have to run any loop that should be the P start less than the P end. It will indicate that you have only one, means you have only the one element. And the moment you see this is greater than 1, that means you have already finished the element, right? So again come here. So you got the 1, 6, 7 here, right? This is only one element. This is only one element. So of course this is only one element. This become your root. See here, and this is the 6, 7. Of course, this will go the right side, and this become the 7. Right? So sorry, I mistake here. So this is your left side, and this is your right side. Left side is 1, and right side is the 6, 7. Right? So this become here, and if you see here, again this is become the parent, this side. And that is only one right side, it become the 7. So if you can see that we are constructing the simple binary search tree. So what is the logic here? And you did the same thing here also, right? So we are doing the recursive way, and every time we are finding the 5 things. What is the root element? And for this left side, what is the starting, what is the ending, and for the right side, what is the starting, what is the ending. So your root element would be the P start always. Your left side subtree will start from P start plus 1 and ending with the position minus 1. Right? If you see here, start from P start plus 1 and ending with position minus 1. And for the right subtree, start from position ending with P end. So start from position ending with the P end. That's what you have to find out, and you can construct your binary search tree here, right? Let me show in the code, then we will again if any things we explain over there. First write the recursive method, give the name build, and I have to pass the three things, right? P start, P end, and this is the array that have the preorder traversal informations. What is the termination for the recursive method? If any time your P start is greater than the P end, means we have to stop our recursive things and return the null. Okay, now take the wrapped-most element, that is our root, right? So make the root means we have to take the wrapped-most. Wrapped-most is means P start. So when you call this method, I will pass. When you call this recursive, I pass the 0 because starting time P start is the 0, means the first element of the preorder, and is the length minus 1, right? And of course we have to pass the preorder. So this is my first element, right? So this is about the root. So make this root here. So tree node root is equal to tree node. Pass these things. So we got the first element. Now what is the important thing? We have to find out the position, right? So we have to start the position immediate next after the root, because we have already consumed the root. So wrapped subtree would be there immediate after the root till the greater element more than the root, right? So take one variable position and start from the, and we will do till P start is less than the P end, and one more condition, that is P start value should be less than the root value. In my case, root value just we create this root, right? And we have to move this while loop till we get the immediate greater than the root value, right? So now we have all these things here. So if you have everything, then make the wrap tree, call the build. What is the left side starting? Left side starting is P start plus 1, right? P start plus 1, and ending is position minus 1, that we explained on the board, right? Position minus 1, and of course we have to, and for the right side call the build. For the right side starting is the position and ending is the P end, and pass the array and return root. That is the complete code. Let me see after running this. So let me run this code, take the first cases and run it. So this is saying the wrong answer. So why it is? So we have to run this till P start less than the P end, right? This is the running condition. It was the terminating condition, and it was the running condition till your P start is less than the P end. Yeah, working fine. And this is the next test cases what we have explained on the whiteboard. So the same thing I have taken here, and I'm expecting this one and run that. It's already run, and you can see code is working fine, right? So let me submit this code, must be accepted. I have already tested it, and please don't forget to subscribe the channel and share your channel. Okay, so we got that array out of bound exceptions. Where array of I bound exceptions we find out, right? So for that what you have to do that, yeah, for the one corner case what you have to do, for the one corner case anyhow we have to we have already incremented the P start, right? So we have to start from the POS, not from the P start. So for corner case you have to take care for this, because the my position will start from after the P start, right? Now let me first run it, working fine or not. Is working fine, and then submit. So take care for this here. Yes, yeah, submitted. So this time you have to check that this part. So instead of the P start we take the position for the some corner cases. So this is your complete code, and if any questions let me know in the comment box. I will try to give the answer, right? So yeah, thank you very much.